one more example, and we will move on to inequalities. So isolate, this one needs to be isolated. So we're going to have to write the problem down again. And what part of this problem needs to be isolated? We only want what's the absolute value and what's inside. So what do we want to get rid of? We want to get rid of the -4. So how do we get rid of -4? We do the opposite. What's the opposite of -4? It is +4. So we're going to add 4 to both sides of our equation. That isolates our absolute value bars. So we get -2 + 4, I believe that's a +2. So we've isolated that. Now we split it. So what do we mean by split it? We rewrite this without the absolute value bar, x + 1, and we say could mean go to the left 2, or x + 1 is our starting place. So we don't know where we are. We're starting somewhere. We're going to move to the right 2, and then we're going to move to the left 2. And we're about to find out where we're going to end up. We're going to get these two numbers right here. So we've split the equation. I did the left side and then I did the right side. Notice that what's inside the absolute value bar is not changing. All I did was remove the absolute value bar. A lot of students want to change this to a -1. Don't change what's inside the absolute value bar. It should stay that until we do this split. Okay, so now we solve each one of these. How do we solve? How do we get the x by itself? We undo what's happening to the x. So we do -1, -1, and that adds to 0. So we're left with x equals -3. Or how do we undo +1? -1, -1. That adds to 0, and we're left with x equals 2 minus 1 is 1. So we know that we're going to be -3 if we move 2 units to the left, and we're going to be at +1 if we move 2 units to the right. So our endpoints then are at -3 and at +1. And of course, you can just count back 2 units and see where we ended up, where we started. So this is moving 2 units to the right. This is moving 2 units to the left. This is my graphical proof that my answer is correct. Then the algebraic proof, of course, would be to plug and chug. So I would rewrite the absolute value problem, leave the x out. Uh-oh. Yeah, I did it. No, I did. I'm writing the wrong one. Sorry. I was looking at part A. So I'm doing this one. Rewrite the absolute value problem. Leave the x out. And plug in this x value. Plug in -3. You get -3 + 1. That's a -2. The absolute value of -2 is 2. And 2 minus 4 is -2. And I get a true statement. -2 is equal to -2. Now I've got to try the other one. Rewrite the absolute value problem. Just leave the x value out. And what am I going to do? I'm going to plug this number in the place of x. So that number went in the place of x. 1 + 1 is 2. The absolute value of 2 is 2. 2 minus 4 is -2. And I end up with another true statement. So I check both of these checked. That's the algebraic check. This is the graphical check. This is showing by graphing that my answer is correct. We've moved to page 13. So what changes if you're dealing with an inequality rather than an equation? Not much. Notice the steps still say isolate. Step number 2, split them. It says write 2. I say split. Step number 3 right here says solve. Our graph is going to look different, okay? Our graph is either going to be a graph where I have 2 branches shaded, or whether I have the stuff between the two endpoints shaded. So I'm still going to find two answers, and I'm either going to shade what's less than that answer and then greater than that answer, or I'm going to be shaded what's in between. And of course, we still use our fill in the circle or don't fill in the circle rules. So here's the example. They isolated by saying -1, -1. They split. They said -1 right here and -1 right there. That's where they got the 5. They split. Notice they dropped the absolute value bar right here. This was the absolute value bar. Now it's gone. The 2x plus 3 stayed 2x plus 3. They wrote down a +5 and a -5. Now this part is different right here. Notice that when you write down the -5, you do change the direction of that inequality. And yes, you'll do that every time for the negative value. Again, I would write the -1 first, just because I think being on the left helps me remember that that's why it's negative, is because I'm moving to the left. But then they solved each side of these equations, and then they graphed the two solutions. I am going to, of course, write an example with you in just a second, but I do want to talk about the example that's in your book. Here, they did the same thing. They isolated the absolute value bars. They had said -5, -5. That's why the 2 became a 7. I'm sorry, the 7 became a 2. They dropped the absolute value bars, and they wrote theirs interestingly. They put the -2 in front and the +2 in the back, which is a great way to do it, but you're having to solve two equations at the same time. You don't have to do that way. You can just write this equation down, and then the other equation would be this one. Okay, so you can write it down as two equations just like they did up here, or you can write it with just one equation. Here you would add one here, add one here, add one here. Then you would divide everything by 3. That's where they got this, and then that lets you know that you're going to shade in between. Okay, so here's an example. Isolate, split, solve, and check. So we're going to take this absolute value problem. This says absolute value of x plus 2 minus 3 is less than or equal to -1. We're going to isolate. That means we need to get rid of that +3. We're going to need to get rid of the -3. How do we get rid of it? We do the opposite. We add 3. So I'm left with the absolute value of x plus 2. That's added to 0. It's still less than or equal to a -1 plus 3. That's a +2. So now I'm ready to split it. Now this is the one where you can, you can do it two ways. You can write two equations, and I would drop the absolute value bars, switch the inequality, and write -2. And then the word that goes in between this one is and. Anytime it's less than or equal to, it's always and. Then you write x plus 2 is keep the symbol the same, and then keep the +2. So notice that when I wrote the -2, which means that I could move left 2, I'm going to change the inequality. Why? Because I said so. This is one of those reasons, one of those cases where it's just better to do it because I said to than try to figure out why that's happening, because the why is a little bit more complicated than you want to think about. So now that I have them separated, now that I have the two equations, I'm on step number 3 right here, which says solve each one of them. So the solve part just means get the x by itself. So I'm going to do -2 minus 2. That adds to 0. X is greater than or equal to -4. And x, I need to get the x by itself, so how do I undo +2? I do -2 minus 2, and I get x is less than or equal to 0. So my two endpoints are at -4 and at 0. And since they both have bars underneath them, that's why I'm filling them in and making them solid. Now this says I want numbers that are bigger than bigger than -4. So where are the numbers bigger than -4? This way. And at the same time, I want numbers that are smaller than 0. That's what less than 0 means, smaller than 0. So where do I find numbers smaller than 0? On the left side of 0. So I'm going to be shading this one this way. So that's how I know that the shading goes in between. I can also tell just by looking anytime once I isolate the inequality right here, if it still says less than or equal to, then less than or equal to is always going to be shading in between. And that's why we could have worked this one by saying -2 is less than or equal to x plus 2 is less than or equal to +2. When it's a less than symbol, you can do it all in one. So I put what was in the absolute value bars in the middle, and then I put the -2 on the left, the +2 on the right. And yes, those will always be less than symbols. So I'm going to solve for x right here by doing the opposite of this, and I'm going to say -2 here. I'm going to say -2 on this side of the inequality, and I'm going to say -2 on this side of the inequality. So I kind of have 3 places to do it. That adds to -4. That adds to 0. That adds to 0. So this right here, if I write it correctly, this says the exact same thing that this says, because saying that -4 is less than x is the same thing as saying x is greater. I'm sorry, let me do it again. -4 is less than x says the same thing as x is greater than -4. I'm talking about all the numbers that are bigger than -4. Here I'm talking about all the numbers that are bigger than -4. So I say the same thing, I'm just writing it 2 different ways.